and thank you for inviting me to this very beautiful place away from New York City where the weather is horrendous. I have the opportunity to come here and learn about your organization, and I see that we share a lot of interests. So what I'm going to be discussing is something that we became interested on a couple of years ago. As being editors, we began to face a lot of retractions. And this is a story that's the origin of it, and I will take you there. But I want to begin by, by pointing out that if you look at the problems of humanity, these are the big problems. Whether the euro crashes, whether we have a war here and there or something, these things are terrible and great problems for the moment. But if you look at our species, these are the problems that we're facing. Climate change, a faltering green revolution, which is resulting in putting a significant percentage of our food supply at risk, any pandemics, a rock from outer space, a need for new energy sources that's pretty much tied into climate change, and psychopaths. That, whether you like it or not, is a scientific problem. Individuals can take over countries, industrialized countries, and you could see the amount of suffering that they can deliver to humanity, and there are plenty of examples of that in the 20th century. So all these problems, in my mind, pretty much the solutions require in scientific and technological advances. The world population is now 7 billion plus, and if you see the rapid rise on the bottom, it coincides almost exactly with the scientific and industrial revolution. Our species began to command the capacity to control food, control the environment, and has been wildly successful. However, out of these 7 billion people, only a minute fraction is involved in scientific endeavors. And so the solutions to humanity's greatest problems rely on this population that includes the audience here. So therefore, the scientific enterprise must function as best as it can if we are going to continue to do well as a species. The richest person in the 19th century was Queen Victoria. Her husband died of typhoid fever. She lost children to diphtheria and hemophilia. During her reign, 1 million people starved in Ireland. The hemophilia trait was passed to the houses of Europe with devastating consequences. For example, the Romanov family in Russia. She went as far as the south of France when she traveled. Her palace was full of smoke, and her toilet, at least initially, was chamber pots. So the point that I want to get at is, within a little bit over 100 years, none of you want her life. And the reason that none of you want her life is because the great technological advances that have been made this century, such that you are richer than she is because of what you can do and because of the life that you have. And what we would like to do is to see this continue, such that 100 years from now, the average person is richer, has a better life than the richest person today. To give you an example of the power of science, technology, and innovation, if you look at the European history between the fall of the Roman Empire in the late 5th century and the high Middle Ages, the growth of the economy was 1% in 800 years. Now in the United States, we get very upset when the growth rate is anything less than 3% per quarter. That's just an example of what we expect. All prior generations, or most of them, were born and died in the same world, and yet today we can barely cope with the scientific advances and technological advances, as you see by all around us. But there are problems in the scientific enterprise. So the problems can be categorized as external and internal. External problems are inadequate funding, societal focus on short-term rewards, educational debits. We're training people who really are not, when they arrive in graduate school, are really not up to the task. A reduced focus on basic science, workforce imbalances. Give you an example of that is the aging of the population that goes in science is the number of NIH grants by age. We also have huge imbalances when it comes to gender, and I'll mention that later. We live in an anti-intellectual era. Basically, all you have to do is make a scientific announcement, and immediately people jump on it, and science is constantly under attack, climate change deniers, creationism, you name it. Internally, you have a problem of disproportionate reward to winners, an obsession with surrogate markers of importance, things like impact factor, the age factor, over-specialization, or scientists are so specialized that those who are working on the mitochondria don't know what's happening in the nucleus a couple of angstroms away. This is just an example of what we have created. We have an economic system that will address and poor communication with the public. If you want to ruin a dinner party, invite a scientist and ask them to talk to them about their work. Not everybody, but the majority of them will talk to you in such jargon that you will lose it. So if you look at the solutions, to the left, they are political and societal. To the right are scientific reforms. We can't really do much scientists on the left, but we can focus on the right part of this, and that's what I'm interested. I'm a working scientist. I basically run a lab. My job depends on grants, and this is what I do for a living. So the problems of science have already reached the general media. 2 years ago, the Wall Street Journal asked the question, how much science is reproducible? Well, turns out that when people begin looking at this, not much. Here's an example in Amgen where a company put in a lot of effort to try to replicate a drug for cancer, and they weren't unable to. And this is this has been addressed in a paper in Science by Dr. Ellis, in Nature, which has shown that roughly 9 out of every 10 drugs in cancer fail after they leave the laboratory, and they often fail because the work cannot be reproduced. You basically have poor quality of preclinical data, you have laboratory errors with cell lines, you have over-reliance on mouse models, and generally poor laboratory design. So as we began, if we're going to maintain this technological growth, we got to clean up the act of what's going on in the laboratories. This not only extends to cancer drugs, this is drug discovery, other types of drugs, and this is a paper that appeared in Nature, reviews the drug discovery, and showed that roughly 7%, they could reproduce 7% of the results by following what was in the materials and methods. And it gives you an example of the problems. Others are beginning to question what is going on. Dr. Ioannidis has raised the issue that the greater the financial and other interests and prejudice in the scientific field, the less likely the scientific findings are to be true. And he's stated an obsession with winning funding has gone a long way towards weakening the reliability of medical research. This was the cover of The Economist in October. So the problems of science are on the cover of major periodicals. Trouble at the labs. Scientists like to think that science is self-correcting. To an alarming degree, it is not. Problems of scientific research, how science goes wrong. Scientific research has changed the world. Now it needs to change itself. So a few years ago, this began in 2011, I began to work with Frederick Fang on the thought that science needed to be reformed. And within science, we thought we needed methodological reforms and cultural reforms, and outside of science, structural reforms. However, before you're going to convince anybody that there has to be a reform, you need to find unequivocal evidence of a problem. And retractions provide unequivocal evidence of problems in science. This is scientific literature. If there is a problem with the literature, you can't get away from it. So our goal was to analyze the literature. And we began to do so because retractions provide unequivocal evidence of failure in science. Any retraction is a loss of effort to all collaborators, loss of resources, loss of prestige and reputation, and retracted work can mislead fields. Retractions are increasing at a rate that is much faster than the growth of the scientific literature. This is some work that we published last year, but what you see a drop at the end, that is an artifactual drop because recent papers have not yet been retracted. But the modeling, if current trends continue, the number of retractions will continue to increase. Retractions fall into two categories. Those are honest and dishonest. Honest retractions are good for science. We need to correct the literature. If something is wrong, you need to pull it, and there shouldn't be any consequences to people. People make errors. There are statistical errors, logical errors, and sometimes things are irreproducible, not because of any misconduct, simply because systems are not stable or whatever. Dishonest retractions fall under the category of outright falsification, modification of data, cleaning it up so that you can get it published, outright fabrication of data, and other types of misconduct for which there is a long list. So one of the things that we ran into when we began to look at this is we noticed that there were differences in the retraction numbers per journal, and we created the retraction index. And then we decided to plot it against the impact factor, and we got this relationship. And what you can see is that the journals that are best known and most prestigious tend to have more retractions. Science reprinted this, and their argument that came back to us is what Monica Bradford said. Basically, she suggested that the extra attention on high-impact journals is responsible for the fact that the higher rates of retraction. And what we decided to do, however, was to look at what was causing this. And we published in PNAS a year ago now, or roughly a year and a half ago, that the majority of retractions are due to misconduct. And we were able to make that conclusion not by reading the retraction notices. The retraction notices are themselves often fraudulent. In other words, people write, the paper is being retracted because figure 2 cannot be reproduced. So you think it may be an honest error or something like that. But if you now take the name of the authors and you correlate it with the findings of misconduct at the Office of Research Integrity, you find that a lot of those papers that appear to be honestly retracted turn out to be not the case. Where retractions come from? The established scientific powers, the United States, Germany, Japan. Basically, you tend to get primarily fraud and suspected fraud. Plagiarism seems to be primarily a problem of rising powers, in particular when English is not the native language, and duplicate publication is another type of misconduct that is out there. I believe the last two will be solved by technology, because right now all journals are moving in to identify. Basically, if you submit a paper to a journal, they compare it to the published literature, and I think that will go away. But the problem of fraud and suspected fraud is a much deeper problem. How common is research misconduct? In 1981, young-looking Al Gore said, one reason for the persistence of this type of problem is the reluctance of people in high places to take this matter seriously. And he may be right. How common is misconduct? Here are two quotes from the 80s. Philip Handler and Daniel Koshland both basically argued that this was something very rare. Philip Handler says, one can only judge the rare such acts that have come to light as psychopathic behavior originating in minds that have made very bad judgments, ethics aside, minds in which at least one regard may be considered deranged. And Daniel Koshland said that 99.999% is accurate and truthful and certainly has no data, and both of those statements, I believe, are wrong. In fact, they are beginning to look at the problem of questionable research practices. Fanelli has been one of the leaders on this, and this is a small study that was conducted in which found that if you just went around and asked people in labs, what have you seen around you, that the numbers you can see there on the right are astounding. It's as high as 40%. And there's another paper that appeared last year pretty much confirming this. And these questionable research practices are from everything from not including data to outright fraud, and there is a whole gray area down there. But I urge you to see how widespread this phenomenon is, and if it is so widespread, then to ask the question, why is it, and what are we going to do about it? What are the incentives for research misconduct? Monetary rewards, career advancement, the priority rule, and winner-take-all economics of science and research funding. The economic system of science is winner-take-all, and prestige is the currency. Prestige is conferred by peers in society. Prestige is related to credit. The sources and consequence of prestige are prices, grants, jobs, and publication venue. So the bottom line is, what is winner-take-all? And the priority rule, it means those who publish first get all the credit. We have argued that this is one of the problems, that we need to think of new economics. The intense competition among scientists has led to abuses. and is there a better way? This is something that was published in Science. Basically, countries, institutions reward people for publishing in high-impact journals. Brazil has established something called the quality scale. And so basically, the higher you publish, the more likely you are not only to get advancement, but also to get direct monetary rewards. And here is a huge problem, and that is the shrinking investment of our nation in research and development. So one of the contradictions of today is that we worry about the size of the economy. We worry about unemployment. And you see what I told you about the growth of the economy in the 800 years prior to the High Middle Ages. So basically, the country is spending less in precisely what it needs to do to take its citizens forward. I will tell you some notable cases of misconduct. This is a well-known case. Wakefield, Andrew Wakefield was associated with the publication, The Association of Measles and Autism. And this is now all over the news. Andrew Wakefield tries to shift blame for the UK measles epidemic. You can all be foot soldiers on this. Think about it. Measles is the leading killer of children historically. Society invests and develops a vaccine that prevents measles. An association is made based on fraudulent data, and you cannot get this, and you can't get the idea out of the population. So I ask you, when you engage with your fellow citizens, when you go back and you hear anything like this, point out that in fact, much of this association, and it's all over the press, some of it was fraudulent. Another case of more than 80 retractions by JOACHIM BOLDT. Basically, he did studies without IRB approval and contributed hundreds of patients to many studies that subsequently had to be retracted, and all that work has been lost. And in fact, he contributed so many patients that many of the conclusions that were made were no longer tenable if you pulled out his data. And this is translated into changes in clinical practice, and it's real consequences of fraud. This was the case of Diderot Stapel. This was a feature in the New York Times, and I urge you, if you're interested in this, to download that and read it, primarily because it's one of the few times in which we have had in detail analysis of what lead individuals to commit misconduct. The case of Anil Potti at Duke University and the Cancer Center, the association of genetic data with response to breast cancer therapy was found to be fraudulent, and this has been featured in 60 Minutes, and it's led to tremendous problems for the institution, not only tremendous problems perhaps for some of those patients, which ended up being put on various groups depending on data that was clearly not correct. One of the things that you may notice is that they were all men. And if you begin going through the literature, you find that males are overrepresented among researchers who commit misconduct. So we published this last year. And the one point that I would like to make, there are 2 points I would like to make. One of them is we cannot exclude the possibility that females do it at the same rate, they just don't get caught. All I can tell you is that the females are not in the pile. So it's either because they're more honest or because they don't get caught. That is in there. The second thing I want to point out to you is that this is not a problem of trainees. This occurs across the entire spectrum of academics, and including very senior people. So if we're going to focus on the problem, we need to focus on the problem throughout the entire academic career. When one retraction to fraud is discovered, it almost always triggers a cascade. So what you see there, the arrow is the first one. At the other end is where it was first published, and what happens is you find that a person commits fraud, and then you begin going through all their papers, and that often cascades into many retractions. Not all fraudulent papers are retracted. This was a famous problem around 1981 when I was a graduate student, and those papers are still in the literature. Another case is the cases of Dr. Summerlin, who was in the laboratory of Robert Good in the mid-70s, and basically was creating data showing that you could transplant from black mice into white mice, and it turns out that he was coloring the mice. And that paper has never been retracted. A book has been written on the subject. Consequences and cost. Well, this is not a very good slide, but I'll just tell you what. It turns out that we have been able to get an estimate of how much it costs the retracted paper. It's about $55 million. Now, on one hand, that is good and bad. It is bad because any dollar lost in retracted data is really a tragedy. But it's also a very small amount compared to the waste that happens in other aspects of government. Retracted papers continue to be cited, and fraud has a devastating effect on the careers of many associated with those papers. I want to talk about the impact factor distortion. And here is the phenomenon that began to happen in the late 20th century, primarily in biological science, that publication venue equal publication quality, something that is ultimately not rational, but is very prevalent. What are the causes of this? Well, scientists themselves. They have equated exclusivity with quality. That is, the harder it is to get into a journal, the better it must be. Well, there's really, think about that. That is not necessarily well followed. The journals have created an artificial scarcity by limiting it. You have over-specialization, such that scientists are relying on surrogate markers to assess value. Administrators can't figure out what science is good, so they basically have an attitude by judging it by impact factor, just plain laziness, so that you let other markers tell you what's important. Prestige by association. We cannot deny that some of the high impact factor journals contain beautiful and correct data, and people want to be associated with that data by publishing in those papers. And national endorsements. We have countries basically giving prizes, monetary prizes for publication in high impact factors. Brazil, I've been told, does not consider in grant renewals publications with impact factor less than 4. And that causes tremendous distortions on how scientists go about their business. What are the costs? It reduces rigor because the venue is equated with quality. Delays publication. Scientists spend a lot of time shopping for journals. You send it to multiple journals hoping to get in. That is time in which the information is not available to the general public. That has tremendous societal costs. It creates a perverse incentives for journals and scientists and may promote misconduct simply because you get such a high payoff from getting into one of these journals. The impact factor distortion is an example of another tragedy in the commons. This was a phrase that was coined by Garrett Hardin to describe the phenomenon of overpopulation, but it's now evolved to be an economic idea, that is, that individuals often act in what is their best interest at the detriment of the whole. And that's an example in climate, whether it is non-renewable resources. So you have the impact factor mania by individual scientists pursuing their own interests in damages the communal enterprise of science. This is beginning to elicit a reaction. Harold Barmes, Nobel Prize winner, who is currently the NCI director, has proposed modifying the CV. So instead of writing down your publications and the journal, you write down one's accomplishments. Now, I don't know whether this could work because you ultimately have to cite the journals, but at least it is a way to get people to say, well, this person accomplished this instead of they publish in this journal, which is some of what happens today. Randy Sheckman has suggested a boycott of the luxury journals in an editorial on The Guardian, and basically said that his lab will no longer send papers to Nature, Cell, and Science as they distort the scientific process. This is very controversial, but at least it's an example of a developing reaction. The DORA initiative, which is the Declaration of Research Principles, tried to get scientists not to judge people for jobs, promotion, etc., based on the journal where they publish, rather on their own contribution. This is going to take time, but this is a cultural, changing culture is always very hard, but you can see that people are responding. So we propose a series of suggestions for reforming science. Some of the problems, over-specialization, the poor quantitative skills, the impact factor mania, the irreproducibility of a lot of the work, the winner-take-all strategy, and outright misconduct. And we have some solutions. For over-specialization, we have thought that one should put the PH back into PhD. Scientists are doctors of philosophy. They come from a much greater tradition. And yet, when the moment they arrive in graduate school, we over-specialize them to the point that after a while, the only thing they know a very, very small part of science. Increased statistical training, focus on findings, not papers, enhanced rigor, checklist, find new ways of giving credit, and an enhanced focus on ethics, software advances, and databases. I found this quote from the Prince. There is no more delicate matter to take in hand, nor more dangerous to conduct, nor more doubtful of success than to set up as the leader in the introduction of changes. For he who innovates will have for enemies all those who are well off under the current system, and only look for support from those who may benefit from it. Well, I will tell you that this has fortunately not been the case for us. We have gotten a lot of support, and I will mention some of that. If you look at the phylogeny of science, we begin with superstition. Superstition gets organized and eventually goes into religion. The great change happened at the beginning of the Enlightenment when René Descartes separated religion from philosophy, and by doing that, created the intellectual background that allowed the scientific revolution. For then it was possible to experiment, and you could just change ideas without challenging received dogma. That science became very successful very rapidly, and one of the things that it's done is it moves away from philosophy. Philosophy continues to have four major branches of knowledge, very relevant to science: epistemology, logic, ethics, and metaphysics. We have begun to put ethics back into science. We make our students, postdocs, and faculty now take ethics courses, but the other areas, and I'm not proposing giving them a philosophy PhD, I'm proposing teaching them on a much broader way of thinking that could allow scientists to take on the world better. I will argue that the previous scientific giants had a lot broader education than today's scientists, and here is a paper that we have just published, basically going over the benefits and the demerits of specialization and suggesting ways by which specialization is necessary. The amount of work and knowledge out there is so great that people have to become specialized. On the other hand, we need to also instruct them on the capacity to reach out, and there's a bigger world out there. Checklists have now begun to appear. Checklists reduce error. Part of the reason air travel has become so safe has been the introduction of checklists. In the operating room, checklists have made a major impact on reducing error. So I'm happy to tell you that Nature in 2013 introduced a submission checklist. They didn't credit us with suggesting it, and maybe it had nothing to do with it, but at least I'm happy that one of our suggestions has been moving forward. Here is an example of simple steps that could be taken to reduce workforce imbalances. There continues to be a tremendous gender disparity in science, whether it is in publications, in advancement to the upper ranks, in grants, and this is well documented by many studies. So one of the things that we did recently is to ask a simple question: what happens when you place a woman as a convener of a scientific symposium? And just the act of placing a woman in organizing increased the percentage of women or female participation at 2 meetings by the ASM by about 70%. And it reduced the likelihood that you will run into an all-male session by almost 70%. And that's a very, very small change. And think about the consequences of that. To get promoted, to get known, you got to speak in scientific meetings. So even a small change like that could have a big effect on addressing some of the problems. One, the economic system science is winner take all. Basically, you have a problem, you set up a competition, you have a solution, and you get a societal benefit. The problem with winner-take-all systems is that they give you disproportional rewards to the winners, and you create a lot of losers. There are alternatives out there, but they are not that common in science. For example, cooperation and ways of sharing credit could also result in the same outcome as societal benefit. The Nobel Prize is the epitome of the winner-take-all strategy. Basically, it is the most recognized prize in science, and we have analyzed the Nobel Prize. This was published a few weeks ago, and we asked the question, is the Nobel Prize good for science? Turns out that we concluded that it was, primarily because it highlighted science to the public and probably did a lot of good just in conveying excitement at the first week of October on scientific advancements. And it celebrated human accomplishment. But we also put a list in there in this paper that is, in fact, very eye-opening. And we show that most Nobel Prizes are controversial. They're controversial because people are left out. But you know, that is a human loss, but there is also the problem that Nobel Prizes distort scientific history. People see a Nobel Prize and they think the problem is solved, or this is how we got there. And it turns out that that often has no basis on reality. And it often sets up fields for unhealthy competition. So we are not advocating the elimination of the Nobel Prize. All we are advocating is, for example, give it to organizations. We now have a controversy with the Higgs. 6 scientists could potentially have been given the Higgs Nobel Prize. And imagine the CERN organization, thousands of people who created all that equipment to that enormous human discovery. And yet you see how it personalizes something that is in reality a group effort, and in doing so disturbs science and pushes further the problems that we have. So winner-take-all systems, there are benefits and debits. They provide strong motivation. Society benefits because you share the information. If you get there first, the first thing you want to do is make it public so you can get the credit. And they do encourage risk-taking. However, the debits are a disproportionate rewards to winners. They create losers, and they often encourage cheating. And the priority rule in science is an example of winner-take-all. Here is an example of something that should be very relevant to people in this room. People fighting over priority on flu papers. This was appeared in Science a couple of months ago. And basically, what they want to do is publish first so they get the credit. But this is an example where we may be dealing with an epidemic, something that could potentially change our entire way of being, and you have a controversy in sharing data, sharing samples, something like that. Society does not benefit when major public health issues are at the mercy of the winner-take-all rule. Consequence of disproportionate rewards. Well, doping in sports. Would Lance Armstrong have dope if they only gave him a medal? Think about that. You create situations where cheating is the incentivized, because incentives are so great, people are more likely to cheat. We have had cheating scandals, financial scandals. And in fact, if you look at baboons, the males practice winner-take-all. You basically have one male totally stressed out, trying to keep the other males out. The females on the troop don't practice winner-take-all. So even within a species, the genders may have very different reproductive strategies. Winner-take-all systems are not the only economic model for successful organization. The military doesn't have a winner-take-all. You hear generally about the unit, and people are often rewarded individually later in different ways. That's very different. For example, if you read Homer, in those days, it was all about individuals. Winner take all, read the Iliad, and things like that. So this is an example where the military has moved away to find a way to ensure and reward cooperation because it's in its interest. Industrial research is a very different model than academic research. Charity certainly is not a winner-take-all, and I don't know what the economic system or religion is, but it's certainly not a winner-take-all. So what is the situation today? Well, the good news is that there is much greater awareness of the problem, especially in the general media. The problems of science are out there for anyone to read about. Many scientists are increasingly concerned. So I think the fact that it's in the general media is good, because the public are ultimately paying for science. On the other hand, it raises the scary possibility that the public will get totally fed up and cut funding, and I think that will be disastrous given that the major scientific problems of humanity are, the major problems of humanity are scientific. There are small steps being taken towards reform. I told you about checklists. The the DORA initiative, suggestions of a new CV format. However, the scientific leadership is checked out. You don't hear anything from the National Academy of Sciences, the Institute of Medicine, or the National Academy of Engineering. And the battle is being waged primarily by journal editors and individuals. So our papers are being noticed. For example, the New York Times wrote a major article based on our calls for reform, and Science featured us, that's Ferric Fang, in a major article on basically bringing in all these problems. So I think that just by speaking up and bringing this discussion, a difference can be made. But we need everyone, we need all of you to become foot soldiers in this battle to improve the scientific enterprise. So what can you do? You can support science. You can demand high standards and rigor. You can ask questions. You should focus on content and don't venue. If somebody says to you, this paper was published in, fill in the name of the luxury journal, don't ask, why are you saying that? Is it because you think that the paper is better because it's in that journal? Tell me what's in the paper. Have a very different discussion. And if they say, oh yeah, that's a very prestigious journal, tell them about our findings. They have a very high retraction index. So that's an example where just a discussion among the stakeholders can begin to change how we see things. To look for the equivalence trap. What is the equivalence trap? Notice today that whenever any major finding is made, the media, you could have 99.9% of scientists say, this is a problem. One person says this is not a problem, and the media puts them in the same pedestal. I'm sorry, there are things out there for which there is a tremendous amount of scientific data, and yet the way that science is conveyed to the public is to set up these controversies and equivalence traps, and and we need to fight that. And I think we need to be optimistic. Science is a very young human enterprise, and within, 8-10 generations, it's totally changed the world in many ways. I want to, despite all the problems, we're living in an age of tremendous scientific and technological advances. When I was a medical student and I went into Bellevue Hospital, if you had HIV, people died within months. Today, HIV is a chronic disease. We have over 22 drugs, and people who are managed well seldom die of AIDS. This has happened in a blink of an eye. Hepatitis C may be curable in a couple of years. I mean, we have had, for example, the beginning of similar wonder drugs against cancer. And I think this is only the beginning, and we're going to see a lot of progress. But a lot more progress could be made if more than 1 out of 10 cancer drugs made it. We have new vaccines. We have curiosity exploring Mars, human curiosity. It's out there on the planet. And certainly last year we had the finding of the Higgs boson and the validation of the Standard Model, and that's tremendous consequences for physics. And I would like to end with acknowledgments to Ferric Fang at the University of Washington, John Bennett at Rutgers, Grant Steen, and the American Society of Microbiology, because they have opened up a lot of their records, and it's allowing us to do a lot of this important research. Thank you very much.